Okay, after making all of these like combinations and find out the effects of them, we want to see that, okay, we want to know which ones are significant. As we said in the previous slides, like we have two methods. It's like that we would go with the normal priority plot or we would go with the ANOVA table. So let's talk about the ANOVA table here. So with the ANOVA table, what did we have? We had like our factors, right? Their interactions, like representing our regression model, and then we would have like as a source of variation. And then we would have our error, and then the total. Like that's how we would deal with the ANOVA table. So for the regression parts, like when we have we have like ABC, like we would have our factors and then their interactions, like 2-factor interactions and 3-factor interactions. So we would have write down all of those ones as source of variation, and then we will need to write down the error. For the error part here, we are gonna find out the mean square error, which is the variance estimate. So I'm gonna share my screen with you. Let me just see. Okay. Here. Look at here. We want to find out the mean square error. For mean square error, what are we going to do here is that temperature, our rate, and our catalyst type, that we would have A and B. We're going to read the response one, and then we would say, okay, so let's say, for example, for this operating condition, the variance is like 1.2. The degree of freedom, we have 3 data points, right? So we would say 3 minus 1 is going to be 2 degree of freedom. And then for this one, we are going to get the variance of it. And then again, we would say 3 minus 2, which is going to give us the 2 degree of freedom. So when we are looking at it, one is 1.2, the other one is 1.16. So we would say they're very close. One is 1.1, the other one is 1.2, in fact, right? So we are going to use the pooled variance estimate here. For pooled variance estimate, the equation that we had, it was like, we would say, like whatever, let's say this is S1, this is S2. It would be N1 minus 1, S1 power 2. And then you would say plus N2 minus 1, S2, like the second variance power 2. And then you would divide it by the total degree of freedom, like N1 plus N2 minus 2. So it would be for this one, N1 minus 1 is going to be 2 minus 1 is going to be 1 times whatever we have here, plus here again is going to be 2 minus 1 is going to be 1 times this one, divided by the, for the denominator, we would say, okay, so it's N1 plus N2, like minus 2. So you would have like the total number that you would have, like 3 minus 1, like 3 plus 3 minus 2, you can say this way. So it's going to give you like the total degree of freedom that you would have. So this pooled variance is the MSE. Now let's go to our ANOVA table. For the ANOVA table, when they are working with this part of the chapter 6, we are talking about the 2 levels, right? So whenever we have 2 levels, we can say that the sum of a square is equal to the 2 power, like n minus 2 or k minus 2, like the number of the factors that we have, and then our effect, like a square of the effect. If we have replication, like fully replication, in that case, we would say like R and then times, like the rest are the same. And here you can see it's written R is the number of the replicates. So in this example, we don't have fully replication. Because of that, we would say R is equal to 1. And then we would say that we didn't have any, like, we didn't have replication for all of the A, B, and C. So we found out the effects, like from the table. When we want to find out the effect, there is one way that you would do is that, as we said, you're going to get the like positive average of the positive one minus the average of the negative ones, and then you're going to find the effect of it, right? So effect of the main effects or the interactions in your prediction. If you want to write down a code, what are you going? Another way that you could do is that we always say that you are going to have contrast divided by the divisor. contrast means that whatever negative like sign that you have times the response that you would have. So let's say for if I were adding the response like on the, for the last column, or if I had the response here, I would say that like -1, for example, if I was talking on A, I would say -1 times the difference 1 times the response for this level, for this row. And then I would say again this plus this -1 times the response for this operating condition. Then you would divide it by the divisor. For the divisor, we have this equation that would say it's number of the replicates times 2 power k-1. K is the number of factors. Like for example, remember in this example, because k was 3, like we had 3 factors, so the divisor would be 2 power 3 minus 1, which is going to be like 2 power 2 is going to be 4. So that's another way of calculating these effects. We can do any of them if you want. The contrast effect is equal to contrast divided by divisor, and you can find this equation that I was just verbally saying that in the like there's a cheat sheet that I made the equation, so you can see that over there in the last page of it. It's written. I'll personally go with both of them, like you can say whatever you feel more comfortable, like the equations that they're in front of you, and like the data points are in front of you, and you have the equations on the other hand, so you can decide to go with which one. They're going to give you the same answer. So let's look at it. I found that the effect, let's say, the sum of a square, I'm going to go with this equation, like 2 power n minus 2, and then effect power 2. That you have. So we are going to find out the sum of a square. For the degree of freedom depends on the number of the levels that you have. For example, for temperature, we had 2 levels. Degree of freedom is going to be 1. For aggregation rate, agitation rate, we had 2 levels, so it would degree of freedom is going to be 1. So we are going to write down degree of freedom here. For mean square, you would say the sum of a square divided by the degree of freedom is going to give you the mean square. And then, so we will do that for the main effects, for the interactions, like 2-factor interactions, 3-factor interactions, and then interactions. And then we would have the error. For error, we said that we will find out from the mean square in the previous page. So we found the error as 1.18. The degree of freedom, we found it here as 4. So here we have the degree of freedom, we have the mean square of the error. We can find out f observed. For each of these, we are going to find out f observed from the table. We read the f critical, and then you're going to compare it, the same thing that we had before. We're going to compare f observed with the f critical, and it's going to give you the value of the value of that if is greater or less than. You can say that which ones are significant. For example, here you can see that, for example, temperature is significant, catalyst is significant. It means that in our regression model, we need to keep them. And then here, interaction of T and R there is not significant. It's like 0.02 is less than 7.71, right? But this one is 661, so this is significant. So definitely you need to keep them in your model. So when you remove these ones from your model, the value of it is going to be added to the error. So it's going to be, we call it lack of fit error, and it's going to be added to the error. So this is the ANOVA. The next one was that to the normal priority plot. So when we are working with the, there is no replication, there is no partial replication or full replication. So in that case, we would go with the normal priority plots. For the normal priority plots, what can you do is that you can plot the effects, or you would plot the contrast. So contrast is that the response times the, it's the coded value, right? These -1 +1s are the coded one. And then we say contrast is like that. We would say this -1 times the response that you would have for this, for this. Then you would, so you can plot the effects that you find on normal priority paper, that you will see that if you have a straight line or not. So whatever, when you draw that and you have the straight line, whatever effects that they are deviating significantly from the pattern, then it would show that those factors or interactions, their significance. And that's another way of finding if the factors or interactions like their significance. And if you want to read this, it's like that. I just said the last 2 bullet points, but here's that if the observed results occurred as a result of random variation about the fixed mean, then changing factor had no effect. Therefore, the calculated effects being difference or average would be normally distributed. So we would have the normal variety plot, and then we'd see that if the when you draw the effects or contrasts, you will see that if they are deviated significantly from the lines that we would have, then you would say they are significant. So look at this one.